Hello, my name is Mike Jarrett. I'm a programmer and analyst at Population Data BC, a linkage agency at the University of British Columbia in Canada. Welcome to my virtual presentation at IPDLN 2020 entitled Evaluating PPRL versus Clear Text Linkage with Real-World Data. This project is a collaboration between PopData in Canada and the Centre for Data Linkage at Curtin University in Australia. CDL has developed LinkSmart, a linkage application which can perform linkages as both clear text linkages and as encrypted linkages as part of a PPRL linkage. PPRL stands for privacy preserving record linkage, and this is where the identifiers for a linkage are encrypted by the data providers before being sent to the linkage agency, and the linkage is done on those encrypted identifiers, not on clear text. One of the main problems that arises in PPRL is how to do partial string comparisons as you would in a clear text linkage. One method to do partial string comparisons is to use Bloom filters. And for a good background on this, I refer you to Rainer Schnell's 2009 paper, Privacy Preserving Record Linkage Using Bloom Filters. The principle is that you can separate a string into bigrams and hash each bigram separately, compute the modulus based on the length of the Bloom filter that you want, and then flip the bit of that position to 1 for each bigram. So two identical strings will provide identical Bloom filters, and two similar strings with just a difference of, say, 1 or 2 bigrams will provide very similar Bloom filters with just a difference of 1 or 2 bits. And you can compute the difference between two Bloom filters using something like a dice coefficient, which is what we use here, which just compares the number of similar bits in the Bloom filters divided by the total number of bits. So we use a dice coefficient as a measure of string similarity as an alternative to, say, a Yarrow-Winkler comparison that we would use in a clear text linkage. The LinkSmart PPRL linkage pipeline, the first step is encoding the data using the LinkSmart envelope builder. String fields like names are converted into Bloom filters. Other fields are just hashed, a simple hash for binary comparison. This is a probabilistic linkage, so field weights are determined using the expectation maximization algorithm. The linkage is performed using binary comparisons for hashed fields and dice coefficient for bloomed fields. And weights are determined for each candidate link. And the resolution in this case is done by the highest weight candidate for each record. The clear text linkage is the same, except the fields are not encoded. For this project, we took a look at 2 different data sets, which I'll refer to as data set A and B. The first data set A is a fairly small data set with about 37,000 records that we link annually at PopData. There's very little missing data in this data set, and the vast majority of records have a personal health number, which is a unique identifier for everyone registered in the public health system in BC. So we consider this a very well identified and well understood data set. I won't go into this linkage very much other than to say both LinkSmart Clear Text and LinkSmart PPRL linked this data set to our population directory at very high rates, over 97 or 98%. And comparing the two linkages shows very high similarity between the PPRL linkage and the clear text linkage. So the takeaway from this is, for a well-identified data set, PPRL performs equivalently to the clear text linkage. The second data set that we tried to link to our population spine is a bit different. It's much larger, about 3 million records, and about a third of those records are missing the personal health number, PHN, unique identifier. There are also a number of records with the birth date set to January 1st, 1900. Normally, if this was noticed before a linkage, these would be set to missing values, but we left those in to kind of simulate a PPRL linkage where we might not be able to catch data errors like that after the data had been encoded, since the encoding step is done outside the linkage agency. One thing we found right away is that there was a big difference between the records that have a PHN and the records that don't have a PHN in how well they linked. And so we decided right away to split the linkage between PHN records and no PHN records so that we could try to tease out these differences. So we determined different weights for those two different categories. And in this case, we set the threshold to 11. So we can see here the difference between those two categories. Records with PHN, the linkage agreed almost identically between the clear text linkage and the PPRL linkage, while for records without a PHN, the PPRL linkage had a substantially lower accuracy. However, we do notice that the recall is still quite high. So we infer that the PPRL linkage is accepting a number of links that the clear linkage does not, while the PPRL linkage is missing a number of links that the clear text linkage is finding. We can look at the weight distribution for all the links, and it's quite similar between clear text and PPRL. But if we only look at the links for records with no PHN, we do see some differences here. The PPRL weights are lower, closer to the threshold. So more weights, closer to 11, which we infer to mean there are more kind of marginal links for the PPRL linkage. So the main takeaways here are for well-identified linkages, LinkSmart performs equivalently for clear and PPRL linkages. For less well-identified data. There are obstacles to high accuracy. It's very important to understand your data and to know if it is homogeneous or heterogeneous, and to account for those before doing a PPRL linkage. And I'd also like to refer you to our other abstract on this project, abstract number 222, which is a comparison of LinkSmart PPRL to PopData's standard linkage methods. Quick thank you to our collaborators on this project, and thank you very much for listening.